So now we're going to do oxidation reduction reaction experiment. And this one is to show you that metals have different reactivities and that one will oxidize the other. So we've been doing oxidation reduction. In this experiment, you're proving that one of the metals is oxidized and the other one is reduced. You're going to fill in a table and then you're going to write individual half equations and add them together. And by the end, you'll be able to tell me which of these three metals is the more reactive metal and which is the least, and be able to put them in order by your own data. So primary data, not by looking at a textbook. So what you should have in your kit is this nice wooden test tube holder. You should have these glass test tubes, large ones. You should have these three little samples of metal, a copper piece, a zinc piece, and iron, and a 0.1 molar solution of each. Now you do have 1 molar solution as well. That's for another experiment, experiment 2. But for the first experiment, look for the glass dropper bottles because that's the 0.1 molar. You need less of it, and the 1 molar is in a different container. So what we're going to do, I'm going to take you over to show you the board. This is to represent a diagram to represent your test tube holder and your 6 test tubes, and you're going to put 3 mils approximately. I'll show you how much, not important how much, but roughly the same. 3 mils of 0.1 molar copper sulfate solution in the first 2. In the second 2, you're going to put the same amount and the same concentration of iron sulfate solution. And in the last 2, you're going to put the same amount, same concentration of zinc chloride solution. Now, you are then going to put your metals into these solutions. So have a look at this table. This makes it a little bit more clear for you. Draw up this table in your notebooks, and these metals here, copper, iron and zinc, represent the solid metals that I've shown you already, and these are the solutions without the other part of the compound. So this is the cations, the metal cations, copper 2+, iron 2+, and zinc 2+. We don't need to include the spectator ions. In this case, they're all the anions. The anions are the spectators. They're not going to take part in the reaction, so we make it simple for ourselves by leaving the spectators off and just recording the cations. And you can see that you don't need to put copper into copper. So this is a solid copper going into copper solution. It will do nothing because they've got the same reactivity. So if you want to prove it for yourself, you can go ahead and do it, but I've blanked it out to make it just 6 test tubes because that's easier. If you want to test it, it'll be 0 or nothing will happen, then you can drop your iron into iron solution and your zinc into zinc solution. So you can see how it's going to work. You're going to get a piece of copper and you're going to drop it into iron solution and zinc solution. You're going to get a piece of iron and drop it into copper and zinc solution. You're going to get a piece of zinc and drop it into the remaining 2, copper solution and iron solution. So let's go ahead and do that. So 3 mils. So I do know that, now this is your copper sulfate solution, 40 drops is a mil. So just for the first one, I want to calculate how much that might be. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Not much in a dropper. 14, 15, 16, 17, 18, 19, 20. It's half a mil. Once we establish how much to put in, you'll just copy the level. So that's 1 mil. So I'm thinking might just pour in. I think we'll stick with this amount for all of them, as long as you use the same amount for all of them roughly. So that's going to be one of our coppers, and then we're going to pour some in here. Oh, make sure you don't spill it. You can use your dropper. And then the same with the other two solutions. So this time your zinc. You've got to pour quite fast because they're a little bit hard to pour. And the same with your iron sulfate. Now your iron sulfate oxidizes, so if you see sort of brown sort of scum, that's normal. It's unstable, more unstable. All right, so now we have all our solutions in. We're going to make sure that we drop one of each into the different solutions, and then we need to drop more in. So I'm just going to make sure that I've got all the metals. So you should have a few pieces out. So of course you need 2 of each, so make sure you get that in the beginning. This is the bag that you'll have in your kit. It has some long pieces in it as well, so that's for another experiment, so don't use those. You can see you've got some spares for duplicating sometimes, and to be accurate you should do an experiment 2 or 3 times, so you've got some spare pieces. Just going to get that out, and we've got 2 of our iron. Right, now it does say in the instructions to use steel wool to clean your metal surfaces. Now you might need to do that. I've already done it, so you just take a little bit of this steel wool and rub the surface to get any oxidation off so that your experiment is accurate. Now you don't put your copper into the blue solution, that's putting copper into copper. So you do want to put a piece of copper, and you should label them if you don't know what's what. You should be able to tell by colour though. So your blue solution is copper sulfate. The clear one, the very clear one, is your zinc chloride. And your last one, which is iron sulfate, is slightly straw colour. It's got this tint. It's definitely like a almost, yeah, straw colour. So you can see the difference. So we're going to drop a piece of copper into our zinc chloride, and we're going to drop a piece of copper into our iron sulfate. So that does the copper. And you leave that for 10 minutes, so it's not going to react straight away, but you should see something happen after 10 minutes. You're going to get your zinc, and you want to drop that into copper. So put the zinc into copper. And you're going to put your zinc, piece of zinc, not in your zinc solution. So go to the iron. So now the iron has copper. The 2 irons have copper and zinc in them. And with the 2 pieces of iron, do clean these very well because iron rusts a lot. You're going to put that into your copper. Make sure you don't put it into the one which already has metal in it. And you're going to put it into your zinc solution, the last one that doesn't have any metal in it. And with that, you just wait 10 minutes for a reaction to happen. So here we've waited 10 minutes, and now we're going to check out each solution to see what has happened, and then we're going to fill out our table. I'm going to put the yes for a reaction in green and the no for no reaction in black. So let's take the first one. I'm going to look down in columns because that's easier. So the two blue solutions we're going to have a look at. The first one we're going to look at is, if we're going in order of the table, the iron. So here's the piece of iron, and it's in the blue solution. And if you probably cannot see it very clearly on this video, but if you have a close look, you'll see brown deposition of copper, which means a reaction has occurred. So we're going to say yes in this box here, and you can just say deposition of copper if you want to. And then after that, you're going to have a look at the second one of your copper solutions. So we're going down. Now this time it's the zinc in the copper, definite reaction. It's gone black, and a lot of copper coming out of solution. They're essentially changing places. You can't see the zinc dissolving, but you can see that it's gone black. So yes, and you can just write the reason if you want to, colour change. So that's our copper solution done. And then if we have a look at the next column, which is our iron. So the irons were the straw coloured solutions. We'll just go in order. So the first one was the copper. So if you have a good look at that, there's no reaction in there. The copper's still shiny and the solution's still straw coloured, so no reaction has happened. I'm going to write that in black. No reaction. No reaction. RXN is short for reaction. No reaction. And then if you take the second one in that column, this is your zinc in your straw coloured solution. It's very slow, I have to say. You have to look very carefully. I can see some bubbles and a little bit of sort of yellow colouring just forming on the surface of the zinc. If you leave that a bit longer, you'll definitely see it changing colour to a yellower surface, but you may be able to see it if you have a close look. Leave it longer so I can see it. I don't know whether you can see it on the video. So yes, colour change on metal. On the metal. This was on the metal as well. And then the last solutions, which is your zinc solution, doing it in the order, the copper one first. So a piece of copper in this, there's absolutely no reaction. It's a beautiful shiny piece of copper and a clear solution. So that is a no. And the last one is a piece of iron in your zinc solution, and there is absolutely no change in either the surface of the iron or the solution, colour of the solution, so it's a no. No reaction. No reaction. Okay, so from this you can tell a lot about your activity series of metals. You can tell a lot about what is oxidized and what's reduced, and that's where you're going to start answering a few questions. Just let's have a look at the results and talk about them very briefly, and then you can go on from there. So you can see by the colour that zinc has had 2 reactions in both of the test tubes it was tested in. So it is the most reactive of the metals. So if you're doing a reactivity series from metal reactivity series, from most reactive to least reactive, it's going to be zinc is the most reactive, and then if you have a look you can see out of the 2 in iron, 1 of your iron reacted and 1 didn't, and then in the copper both didn't. So it's iron is the next, oh I've written an F. Iron is the next most reactive, and then copper is your least one. And if you compare that with your known data from secondary sources, it will agree. So that's very good. And then what you can do from there is you can write your reactions. So you've got, let's do this one, zinc solid. I'll just do one to show you. Plus, we're adding it to copper sulfate, CuSO4, putting the spectator back in, gives zinc sulfate plus copper metal. And that's why you can see a colour change on the surface of your metal, because the copper's coming out, the zinc is dissolving in. So that is a balanced chemical equation of what you're doing in that test tube. And then you need to write your two half reactions, and this is for each one. So for each of these reactions, 6 reactions you've got to do this for. So the first is to write the whole thing, your oxidation reaction is your zinc is being oxidized to Zn2 plus 2 electrons, and your reduction half reaction is your copper is going from 2 plus aqueous, picking up the 2 electrons and going to copper solid. Now you need to do this for all 6 of your reactions. And this is an example of one of them. I've just done this one here. That combination. So once you've finished your experiment, make sure that you pack up everything very carefully. These solutions, you know, are not dangerous if you have them tightly packed away in a proper place, labelled with their lids on tightly, and that you make sure that, you know, they're out of reach to anybody who might discover them. With the ones that you've used, you can pour these out down a sink. I'm just going to use this beaker for the moment because my sink is over there. So you pour the solution down the sink. They are so dilute, you can have the tap running while you do that to flush it down. And the piece of metal you can put in the bin. So you get it out of your, probably with the stirring rod. Remove it, and then you toss that piece in the bin. It'll be very corroded and everything. So you can put that part in the bin, and then you just wash these and put them away. So you do that for each single one. Pour the solution down the sink while the water's running, or you can pour it into a waste beaker and then pour it all down the sink, and then put your metal in the bin. All of the same. Put your stuff in your kit box up high, out of reach to any mischievous people who might want to have a look at it, and then you're finished.